I've just finished teaching a navigation course in the Pease Bay area, which is in that direction. I'm just south of Dunbar, about 30 miles east of Edinburgh in Scotland, and I've always wanted to visit this place. This really is, in my opinion, the greatest geological site on Earth, and I thought you may like to have a virtual visit with me. I haven't got a video camera with me today, so I'm doing this on my mobile phone, so I wasn't expecting to make a video. So let's give it a go, and we'll see how it goes. That's where we're going, by the way, down there. That is Siccar Point. I'm going to call this video The Man Who Invented Time, which I know it may sound slightly odd, as how could anybody invent something as fundamental as time? Something that has existed since the dawn of the universe. But that's exactly what I'm going to do today. I'm going to call this video The Man Who Invented Time. But if we're going to do that, I think if somebody really did invent time, I think we need to agree on what time is, and also what is an invention. So firstly, what is time? And don't forget, these are just my ideas, so they may be wrong. Anyway, I would say that time is, I don't know how to put this. Time is the progression from the past to the future. As an example, between last year and next year, time will have progressed. But most people prefer to put names to an amount of the progression. They may say seconds or hours or years or months. And what this does is it makes it easier for us to quantify the amount of time that's progressed, so that we can understand how much time has gone by since, I don't know, one moment and a later moment. So, as I said, I may be wrong, and if you've got your own ideas of what time is, let us know in the comments box. But you're not allowed to mention entropy or the second law of thermodynamics, because I'm not very clever, and that stuff, it makes my brain hurt. Okay, next, what is an invention? Again, these are just my ideas, so they may be wrong. But I would say that an invention is just something that didn't exist before it was invented. But obviously it's not as simple as that when you're talking about time, which that's existed for at least the last, 13.7 billion years? But some things exist, but no one realizes until somebody explains it. As an example, evolution has been a fact for billions and billions of years. So we can't say that Charles Darwin invented it. But what he did do is he invented his theory of evolution, which explained it. I'll give you another example. There was a relationship between mass, time, space and energy before 1905. And gravity obviously existed before 1915. So Einstein didn't invent these, but he did invent his theories of relativity, which explained them. So even though some things may already exist, somebody has to invent an explanation, just like Darwin and Einstein. So for the purposes of this video, we'll say that time is the progression from the past to the future, and an invention is something which didn't exist before it was invented. But if time is a progression from some moment to a later moment, it'd be sensible to think like any progression, say going from a walk from here to over there. There must be a start point somewhere. But even though there has to be a start, a progression doesn't really need an end. As an example, I can walk from here. Instead of going over there, I could just keep on walking forever. So this is how time has been imagined throughout recorded history. The top scientists of whatever period it was, from the ancient Greeks like Aristotle, Plato, Socrates, they would be arguing in the Lyceum, to Isaac Newton in the 17th century, teaching the students of Trinity College in Cambridge. All of these really clever people, they would give lectures explaining how the world was formed and how much time had gone by up to whenever they were giving their particular lecture. I remember from my geography class at school, there was a very famous Dutch scientist called Niels Steensen, who's also known as Niels Steno. And he published a paper, I think in 1669, about fossils. I remember this date as that was the date that Newton became Professor of Mathematics at Cambridge. That's the only reason I remember it. Now, Steensen said that fossils were dead animals which had all died in Noah's flood. Okay, now we have a better idea of what fossils are. But remember, this was in the 17th century. What was amazing though about this 1669 thesis, and this is why it used to be taught in UK English schools, when facts were more important than how we feel about facts. When teachers were allowed to teach facts before politicians got involved. No. Anyway, what was amazing about this 1669 thesis was that it was the first major work which contained a detailed description of superposition. The general idea of superposition is that sediments are deposited on the bottom of lakes and oceans in successive layers, and this means that lower layers must be older than the higher layers. And Steensen's idea was that he'd calculated how long each rock took to form by counting the layers of sedimentary rocks and looking at the fossils. This way he worked out how old those particular rocks were. And when he'd finished counting, he proclaimed that the Earth was approximately 6,000 years old, or just slightly older than when the Bible tells us that Noah's flood took place. Oh, just a quick point on that, by the way. In the year, I think 1650, a bishop in Ireland called James Usher used the Old Testament to calculate the age of the universe. And this work was, was quite famous. Well, it used to be when they taught facts in school. And anyway, it's called Usher's chronology. And in the mid-17th century, it was widely accepted as being correct. Bishop Usher said that the universe was created at 6 o'clock in the evening on the 22nd of October, 4004 BC. Anyway, around 120 years after Steensen published his thesis, in 1788, in this area of Scotland, which is why I'm so excited to be here, there was a local farmer who was also an amateur geologist called James Hutton, and he published an article in a book called I forget the name, The Transactions of the Royal Society of Edinburgh. And his section of that book was called The Theory of the Earth. And his ideas built on Steensen's sedimentary processes. Now, Hutton owned a farm, and he knew that when it rained, some of the topsoil was washed off. And he said that this would be carried away by streams and rivers, and eventually it would accumulate on the seabed as sediment. Now, Hutton said that yes, rock was formed in layers, but over very, very long periods. And over that amount of time, these rocks would be eroded. And this process would continue until the rock layers were broken down into tiny pieces. I think we might call it sand. And these tiny pieces would again be washed to the seabed and form sedimentary layers, which would again turn back into rock, which would again eventually be eroded. And he realized that this forming of rock and then it being eroded down to sand would take much, much longer than 6,000 years. So the landscape that we see around us today couldn't have been formed just before Noah's flood. He also said that rocks weren't everlasting, but in fact, it was It was a cyclical process of rocks being formed, being broken down, and then being reformed. It was a never-ending process. And this is where we get back to time. Don't forget that a progression needs a start point. It's got to start somewhere. And James Hutton said that he couldn't find any evidence of a beginning or a start point in the rock creation process. And he said that that meant that the history of the Earth was indefinitely long. Now, his ideas weren't accepted for two basic reasons. Firstly, he had no evidence. And the second reason, I think, was it's more down to how we perceive time. Okay, can you remember what time you started watching this video and what were you doing then? Yeah, I know. You were awake then and now you're falling asleep, but keep going, it'll be worth it. Another question for you. What were you doing this time yesterday? What about a week ago? So here we have it. You can remember, you can visualize that length of time going back to yesterday or to last week. What about a year ago? Okay, you may not remember exactly what you were doing then, but you'll have a good idea. It doesn't cause any problems. But what about something which happened before you were born? You can't remember it, but you should still be able to visualize it. For example, when your grandparents were children. All right, let's go even further back. What was the world like 500 years ago? This is the year 2024, so 500 years ago it was 1524. So what happened in that year? Well, the first Europeans entered New York Bay. King Frederick I became King of Norway. Oh, and I do remember it was the first public showing of Shakespeare's Titus Andronicus. That took place in 1524. Mind you, I'm not sure you'd want to imagine Shakespeare's Titus Andronicus. It's just totally crazy. And I don't think the YouTube automated AI censors would allow me to explain the full plot of that play. Let's just say that Shakespeare was a bit strange. It ends with Titus cooking two of Timora's sons in a pie, feeding it to her, and just before he kills her. Don't you just love a bit of 17th century comedy? Anyway, I'm sure you can Google it and get more details. What was I talking about? Oh yeah, you weren't there, but it's not too much of a problem to visualize these events. And more importantly, that length of time, 500 years, it doesn't mess about with your brain. Okay, what about 2,000 years ago? In the year 24 AD, Wang Lang became Chinese emperor. I only remember that because I like his name, Wang Lang. It's brilliant. He was a fortune teller who somehow got himself proclaimed emperor of China by a few thousand soldiers. But then the real emperor had him killed. Bye-bye Wang Lang. So however far we go back in human history, it's not really a problem for us to be able to visualize it, even before actual history started, which is when the first writing appeared about 5,500, 6,000 years ago. Before this, people were drawing shapes on cave walls. And again, our minds can cope with that type of timescale. But what about 1 million years ago, or 100 million years ago, or even 1 billion years ago? This is the problem that James Hutton had. We all say the word 1 billion, but can you actually visualize what 1 million of anything actually looks like? It's so unfathomably big. It's very difficult, but it's not impossible. In these modern times, we've become used to speaking about 1 billion of this or 1 trillion of that. But at the end of the 17th century, that wasn't the case. There simply wasn't 1 billion of anything around, except for grains of sand on the beach or raindrops falling in a storm, etc. But nobody had ever tried to count those. So 3 or 4 or 500 million of anything was virtually meaningless to anybody in those days. And this is especially true of time. There was no reason to think in millions or hundreds of millions of years. Why would you, when everybody knew that the Earth had been created about 6,000 years ago, at 6 o'clock in the evening on the 22nd of October, 4004 BC. So what James Hutton needed was proof. That's proof of something which people couldn't even imagine existed. A time progression which was so long that it was inconceivable to the human mind at the end of the 1700s. They knew and they could comprehend short time, today, yesterday, last year, or 100 years ago, and they were okay with long time, up to 6,000 years ago. Hutton needed something much, much longer than that. So he needed to invent something which would prove his theory that rocks were eroded and then reformed, and for this he needed something called deep time, which would stretch back hundreds of millions or even billions of years into the past. Not only did he need to invent deep time, he needed to be able to prove it. He needed to be able to prove it was real. Because without proof, convincing the world of this concept would be a Sisyphean task. He was up against centuries of ingrained belief that the world was only 6,000 years old. Oh, maybe we should introduce an award for the least used word in every video. And I think Sisyphean, that would win this week's video award. It's hardly ever used by anybody. If English isn't your first language, I'm not sure how to describe it. Sisyphean is taken from Sisyphus, who in Greek mythology was the king of Ephyra. And when he was about to die, he tricked the god Thanatos, who was responsible for escorting the souls of the dead to the underworld, into putting on chains meant for him. And so death was trapped, and this caused absolute chaos as nobody could die. Eventually the gods freed Thanatos, and as punishment, Zeus, the king of the gods, condemned Sisyphus to an eternal task, pushing a massive boulder up a hill. But each time he got very near to the top, the boulder would roll back down again, forcing him to start over again endlessly. So Sisyphean means a difficult job that can never be finished. Waffle. Where was I? Oh yeah, Hutton needed to prove that deep time was real. Let's stay focused. And this is where this part of Scotland comes into the story. Now, if you ask most people, what are the most amazing geological sites on Earth? They may say the Great Rift Valley in Africa, which stretches for 6,000 kilometers, 3,700 miles, from around Kilimanjaro up to the Red Sea. Or they may say the Grand Canyon in the USA. Or what about the River Ganges Delta or Mount Fuji? Whilst they are admittedly impressive, I would say that where I am stood now is the #1 geological site on Earth. I know it doesn't look very impressive, but this is where deep time was invented, stretching back billions of years. And this is it. You can actually see it. You can touch it. Right here. This is deep time. How amazing is this? Can you see this line between the two different types of rocks? Yeah, that is deep time. In geology, an unconformity is a place where two types of rocks join together. And this line here, running along, is now known as Hutton's unconformity. Below the unconformity, you can see this sedimentary, greywacke and shale. Greywacke is it's made when large amounts of different sized particles have been moved very quickly, like in an undersea avalanche, or maybe when large amounts of water were moved by a storm in a nearby shallower area. This churns up lots of different material and deposits them all in one place at the same time. As the layers of shale and the greywacke continue to be deposited, the weight of the layers above what was already there compressed and hardened them into these rocks here at Siccar Point. How amazing is this? Obviously, a lot of the shale has been eroded back, which is why you can see all these thin cracks in the greywacke. Obviously, at the time, Hutton wouldn't have known about plate tectonics and how the continents move around the globe. But this section of rock below the join, this greywacke, this was laid down during the Silurian period, just about 500 million years ago, in the Iapetus Ocean. This was an ocean, it was just below what is the equator, and as the sides of the ocean closed together, the rocks between the closures were pressed and folded upright. So these vertical columns here they will have once been horizontal layers of the rock below the ocean floor. And as the ocean sides closed together, it pushed up new mountains here in Scotland, in some parts of Scandinavia, also in Greenland, and in the eastern side of North America. At the time, these new mountains were around the same size as the Himalayas are now. And then nothing happened for around 65 million years. Well, obviously something happened, but it may as well have been nothing, because we'll never know. When you're dealing with deep time at this scale, the only records you have are the rocks. But after the mountains were formed, basically they were exposed to the weather and they were worn down and eroded, as I said, for 65 million years. This is why there are no Himalayan-sized mountains in Scotland, or in Scandinavia, or in Greenland, or the east side of North America. So after this 65 million year period, for which there's simply no record, we start to see the results of the new mountains being eroded. Above the join here, above the unconformity, you can see these layers of red sandstone. This sediment was washed down by streams and rivers and spread out. Each dry and wet season will have brought more and more sand down from what basically was the eroding of the new mountains. The sandstone sediments were over deep time compressed into rock, which is in places around 170 meters thick. It's over 550 feet thick, and that is a lot of sediment. So if you're ever in Scotland looking for 7,000 or 8,000 meter mountains, here they are in the sandstone that was lifted up and tilted by plate tectonics. This is it here at Siccar Point. These are the original massive mountains in Scotland. Now it's eroded. Obviously Hutton couldn't have known how old these rocks were. In fact, it wasn't until radiometric dating was invented in 1905 that the age of these rocks could be worked out for certain. But what he did know, and more importantly he could prove, was that the continuing cycle of sedimentary deposition and then erosion couldn't have been completed in just 6,000 years. In fact, it had to have taken over hundreds of millions or even billions of years. So James Hutton, with his research and calculation here at Siccar Point on the east coast of Scotland, had invented what we now know as deep time. So thanks for watching.